Here we go. We're going to start off with something that I hope is kind of obvious. Let's suppose you know that A times B equals A. What must B equal? If you go something times a number and you get the something back, that's going to be our first Captain Obvious point. If you multiply something by 1, you'll get the same answer. But what we're going to do, Jaden, is we're going to multiply by funny looking ones that will make the answer that we get look different, but it has to be the same answer because we multiplied by 1. In other words, I can write 1 in many different ways. Is that 1? Yes? Is that 1? Yeah? What about this? So one of the things we're going to notice is if a fraction is a 1, if you flip it, it's still a 1. If you put the top to the bottom and the bottom to the top, if you put the numerator on the denominator, denominator on the numerator, still works. Ooh, what about this? Because the top and bottom are the same thing, even though they look different, that's a 1. And it's this type of 1, this type of what we're going to call a conversion factor that we're going to use. Because if we wrap our brain around this, dimensional analysis lets you cut down on your memorization tremendously by using facts that you've already memorized because you've grown up a little bit. Is 4/4 over 1 loonie equal to 1? Yes. So any fraction equals 1 as long as the numerator, top, and denominator, bottom, have the same value, even if they look different. We can use this for something called dimensional analysis or unit conversion. We're going to multiply by a series of funny looking 1s until we end up with the final units that we're looking for. Since we're multiplying by 1, our original value won't change. We're just going to make it look different. We call these strange looking 1s conversion factors or conversion fractions. As an example, here is a conversion factor. 1 kilogram is 2.2 pounds, or 2.2 pounds is 1 kilogram. What that means is this, 2.2 pounds over 1 kilogram, that's a 1. It's a funny looking 1, Jaden, but it's a 1. Or I could flip it. 1 kilogram over 2.2 pounds is a 1. All right. Convert 12 pounds to kilograms. The big question people always have when they have this information is, do I times by 2.2 or divide by 2.2? You don't need to memorize. The fractions can tell you. Whenever you ask me to convert something, the first thing that I always do is I write down what they gave me. 12 pounds. And you're going to find, Liam, one of my teaching strategies is I will almost always try and write down something mindlessly. Because now, is the question blank anymore? No, I'm more relaxed. My odds of success are going to go way up. So for conversion factors, I always, Manraj, write down what they gave me. I'm going to multiply it by a conversion factor. What are my final units? What units do I want at the end? So I need to get rid of pounds. Where are pounds right now? Well, I want you to also realize that this is a fraction. Anything is a fraction because it's always over 1. I'm going to write the over 1 a couple of times, but then I'm going to stop because I'm naturally lazy and just say, can you please remember that it's over 1? Here's my point. This pound symbol, is it on the top or the bottom of this fraction? On the top. So to get it to cancel out in the next fraction, it's going to go at the bottom. So what units are going to go on the top? Kilograms. And my conversion factor, the 1 goes there, the 2.2 goes there. And now I can figure out what I do with that 2.2. Where is that 2.2? On the top or on the bottom? If it's on the bottom, am I going to times by 2.2 or divide by 2.2? Now I know. Oh, it's technically 12 times 1 divided by 1 divided by 2.2. Does timesing by 1 and dividing by 1 make a difference? I'm going to ignore the ones. On my calculator, I'm going to go 12 divided by 2.2. 12 kilograms is 5.4545 repeating pounds. Okay, sig figs. 12, how many sig figs? 2? 2.2, how many sig figs? Technically, how many sig figs should I go to in my answer? So, okay. We're going to change B just a little bit. Can you look up for a second? Instead of 64 kilograms to pounds. Oh, yeah, sorry. Yeah, let's do 64 kilograms to pounds. That's the opposite of what we just did. That's what I wanted. What am I going to do first? Write down what they gave me. 64 kilograms. In my imagination, I'm going to see that it's over 1. Really, what I'm going to see is that the kilograms are on top. So to get the kilograms to cancel in my conversion factor, where are they going to go? On the bottom. What's going to go on the top then? More specific, what units are going to go on the top? Pounds. And with the pounds, the 2.2 tags along, and the 2.2 is on top. So it's going to be 64 times 2.2 or 64 divided by 2.2. How do I know? On the top. By the way, what if the kilograms were on the bottom? How would I get them to cancel out on my next fraction? Put the kilograms on the... We can deal with that. We're going to deal with those too in a second. Anyway, 64 times 2.2, I can do that in my head. It's going to be 64 times 2 is 128. It's going to be 128 plus 12.8. It's going to be 128 plus 12. It's going to be 140. 140.8. Double check me. Am I right? Yeah? Okay. Oh, how many sig figs would I go to? I guess even though I was able to do it in my head to 4 sig figs, just to show off a little bit, I can do math in my head. I guess we're going to go 140 pounds. Psst. Let's ignore sig figs for the remainder of this. I did sig figs in a separate lesson. You practiced it there. Yeah. So, first of all, we use metric prefixes. I call number 1 and number 2 one-step questions because you get to the final answer in just one step. I call number 3 and number 4 two-step questions. You'll see why in just a second. So number 1 says convert 12 megagrams to just plain old grams. What's the first thing I'm going to do? Write down what they gave me. What did they give me? The question's no longer blank. I feel better. In my imagination, Ronan, I see it as being over 1. And of course, you're writing everything down this time, right? Good, because I will check. I want megagrams to cancel. Where is it going to go in my next unit? On the bottom. And I guess just plain old grams on top. But this is not a 1. Mega is what on your green sheet? 10 to the, we're not going to write out the zeros. Let's use the 10 to this. 10 to the 6th. Where does the 10 to the 6th go? Where the mega isn't. The 10 to the 6th is what goes next to your base unit. And so here's my question. Is that 10 to the 6th on the top or on the bottom? So am I going to go 12 times 10 to the 6th or 12 divided by 10 to the 6th? Which is what? Well, if I do it on my calculator, I would go 12 times 10, exponent button, 6. And I get a 12 with 6 zeros. I'm going to probably write that in scientific notation because the question didn't say I could or I couldn't, so I'm going to pick the lazy way out. It's less writing to write 1.2 times 10 to the 7th. I'll write that. I would take both answers on a quiz or a test since this question didn't specify. Number 2. Convert 13.6 amps to milliamps. Anybody want to guess what I'm going to do first?
Write down.
No, even more basic than that. Write down what they gave me, which is 13.6 amps. Question's no longer blank. I feel better. I want amps to cancel. Where is it going to go in my next fraction? And what do I want left behind on the top? I guess milliamps, but this is not a 1. So right now, if I just did that, I'm breaking the rule. What's milli? 10 to the what?
-3.
Where is it going to go? Don't memorize top or bottom. The 10 to the always goes where the metric symbol isn't. It has to go here because that's where the blank spot is. 10 to the -3. Is that 10 to the -3, Liam, on the top or on the bottom? Is that 10 to the -3 on the top or on the bottom? You got a clue. What is it? On the bottom. So does that mean am I going to go times by 10 to the -3 or divide by 10 to the -3? Divide. So on your calculators now, everybody following along on their calculator, easy way to stay involved, 13.6 divided by 10, find your exponent button, -3. Parker.
So the 10 to the always goes in the...
It always goes where the metric symbol isn't. So
the base unit.
it goes next to the fundamental or base unit. Yep. So don't try and memorize top or bottom because it all depends. But it will always go where the milli isn't or where the mega isn't. Do you get 13,600? Now, some of you might be saying, Mr. Dewick, I can do this shorter than that. And if you can, and you always, milliamps, and you always get the same answer, the correct answer, I'm fine with that. There are little tricks where you can kind of count the metric prefixes. Whatever. I don't like having 5 or 6 different ways to do something. This works for me, and I'll show you later on. We'll solve some very complicated questions with this. One-step question because it only needed one step. Two-step questions. We want to convert 13.6 kilograms to milligrams, micrograms. We're not going to do that. We're going to do it in 2 steps. We're going to get rid of the kilo and then bring in the micro. And I'll show you what that's going to look like. First of all, what am I going to do first? So 13.6 kilograms times. Again, Alex, in your mind, imagine the little over 1. Can I stop writing that? Can you just imagine that it's there, please? Okay, so Alex, where is that kilogram? On the top or on the bottom? Right now, here, on the top. So where is it going to go? You're right on the... Okay, so my first step, I'm going to put a kilogram there. And now what I'll start to do, because we're getting more complicated, I'll cross those out, reminding myself I've taken care of it. On the top, all I can put is plain old grams, except kilo is 10 to the what? From your green sheet.
10 to the third.
It's not 10 to the 1,000, whoever said it. 10 to the third?
Yeah.
Yes? Where is the 10 to the third going to go? Where the kilo isn't, which in this case is on the top. If I stopped there, I'd be in grams. What do I want to end up in? Micrograms. So, Alex, we're going to keep going. Another conversion factor. I want to get rid of grams. Where is grams right now? On the, where do I want to put it in my next fraction? On the, starting to notice a bit of a pattern here? I hope so. And I want to end up with micrograms. Micro is 10 to the what? Negative. Where is the 10 to -6 going to go? Why on the bottom? It goes where the metric symbol isn't. So what am I going to type into my... Oh, and you know what? I can cross out the grams, and you can see the only units left are micrograms. That calculus test I told you about, I built, I think it was a 14 conversion factor long chain, but it worked. I ended up with the correct numbers in the end, correct units. I guess you're going to times by 10 to the third and divide by 10 to the negative 6. So get your calculator out. 13.6 times 10 to the third. Oh, I got a 0 there. That's silly. And I get, my calculator gave me an answer in scientific notation, but here's what I don't write. Look up. I don't write 1.36E10. That's what my calculator displays. I know that scientific notation looks like this. 1.36 times 10 to the 10th. I have to fill that in myself. Some of your calculators might display that as 1.36 times 10 to the 10th, but I know the TIs, those of us that are in the TI world, it does that little E thing, which is a computer symbol. So I have to translate it. Oh, units. What are my final units, Alex? Yep. Greek letter mu. A student made that a few years ago, actually, so it's really, really handy. Ronan.
Didn't you just put like 10 to the positive 6 on top?
Sure. Again, if you have a method that works for you and you can get it right, I don't care. What I'm saying is I'm going to teach you one method that works for anything. And if you start getting it wrong, then I'll nudge you into my one method that works for anything. Spencer. I'm not sure what you're asking me. Say it again. Oh, if I had written my answer right there and the units were, I'm okay with that. Yeah. It's something. So there used to be a provincial exam for Physics 12, right? And the first year I marked the provincial exams, I found it was amazing. Matt, you're with me? Leave him alone. How often, because there was an answer space, how often kids would have the correct answer here and then copy it down wrong into the answer space. And we were told we had to mark the one in the answer space. So all the veteran teachers that were marking exams told me, oh, tell your kids, you never put your answers in the answer spaces. Put a box around it. So what you'll often see me do is that habit. I'll put the answer spaces in often because I know some people really like the answer spaces, but I've copied my own answer out wrong so often, I usually put a box around it. Can you see why I call these two-step questions? Step 1, get rid of the unit they gave you. Step 2, bring in the unit that they want, as opposed to just a one-step question where you're either getting rid of or introducing one unit. 2,000, what's that lowercase n? Nanoliters, and we want to convert that to, what's that big M? Megaliters. What I'm going to do first, write down what they gave me. Jaden, where is the nanoliters right now initially, on the top or on the bottom? Where's it going to go in my next fraction to get rid of it? Excellent. Oh, by the way, I will always write a lowercase l in cursive. Why would I not write the L like that? Yeah, we got a problem. So you'll always see me, for liters especially, I'll always do that habit, but I can prevent making a dumb mistake by doing that. On the top is going to be just plain old liters, except that's not a 1. Jaden, nano is 10 to the what? Where's the 10 to the negative 9 going to go? Next to where the nano isn't. So don't put it down there. It goes here to turn this into a 1. And I can now cross out nanoliters. If I stopped here, that would be just plain old liters. But Jaden, what do we want to end up with? Yep. And by the way, I'm also picking on you to force you to get used to looking at your green sheet. Your eyes will start to remember instinctively where to look. It's just a time saver. So this is why I'm kind of working my way around the room a little bit. I want to get rid of liters. Jaden, where is liters going to go in my next fraction? So if I do that, will that get rid of liters? Good. And you can kind of see it looks weird. So liters is going to go there. Megaliters is what I'm going to introduce on the top because that's what I want to end up with. This, however, is wrong because I need to make this a 1. What's mega? 10 to the what? From your green sheet. Where is it going to go? Where the mega isn't. Yep. So I guess, Jaden, I'm going to go 2,000 times 10 to the negative 9 divided by 10 to the 6th. And this method answers for you, Mr. Dewick, do I multiply or do I divide? It tells you. If it's on the top, times. It would be good if there was a dumb, easy way that I could remember that top was times. If I was a good teacher, I'd have a stupid way for you to remember that top is times. I got nothing. You'll have to come up with something on your own. Sorry, I'm a terrible teacher. Did you get, I got an answer in scientific notation, 2 times 10 to the negative 12. So 0.000000000002. 11 zeros, and the 2 would be the 12th one, 12th digit. Units, megaliters. .5 kilometers, convert that to millimeters. Jaden, what am I going to do first? Jaden, Jaden, I did that. Jordan, sorry, wrong name. Jordan, what am I going to do first? Okay, are you starting to pick up a bit of a pattern here? I figure if I can get that going, I think I told you the other day, what I will always try and do is set up a chain of dominoes in your brain. So for unit conversion, write down what they gave me. I think all of you can handle that. Even 342.5 kilometers. All right, Jordan, talk me through it. Where's the kilometers going to go in my next fraction? What am I going to put on the top? And just plain old meters. I write the 2-step. I got to hop my way there. Kilo, 10 to the. Okay, you might memorize a few of these. Go ahead, but do you need to? No. If you're using them over and over and you get sick of looking them up and then you accidentally memorize them, that's fine. That's the only reason you should memorize something, in my opinion. Where's the 10 to the 3 going to go? Where the kilo isn't. If we stopped here, that would be meters. Let's keep going. Jordan, what's going to be in my next fraction? Where's the meters going to go? Okay. What do I want on the top? I guess now I introduce millimeters, and milli is 10 to the. I think you're also going to get an answer in scientific notation. Maybe not. This might just be right around where your calculator might still display it. Mine displays it. Can't be 0 point. You made a typo. So first thing you want to double check is if you're missing a negative in one of your exponents. Did you go divided by 10 to the negative 3 and times 10? Like, okay. Jordan, you got the same as me? I think it's going to be less writing to write that in scientific notation, and I'm comfortable doing scientific notation in my head, so I'm going to use scientific notation. 3.425 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Units, millimeters. Units matter. I will always, on your tests and on your quizzes, On your final answer, I will take marks off if you have missing or incorrect units. Put your pencils down, look up. I'm going to play a recording of a phone call for you. This went viral around 2012, so quite some time ago. See if you can spot where Verizon's operators don't understand what's going on. See if you're smarter than a Verizon operator.
Hey, have you been using My Account handset? It's really convenient. You can check your balance, see your unbilled minutes and messaging use, make payments.
Hey, George?
Yes.
Hey, I'm really sorry about that wait there. Hey, I got Mike on the line. He's my supervisor over here. And, he'll take care of you from here on out, okay?
So let's give you the background. George has already been on the phone for about half an hour, very patiently trying to explain something to Verizon. See if you can spot. I'm going to shrink this down. I want to do that so I can get a little writing window next to here. See if you can spot where Verizon's error is. Listen close.
Thanks.
Thanks, Trent. Good evening, George. How are you doing this evening?
Great. Except that I've been trying to resolve this for 2 calls in over 45 minutes now.
Okay, well, let's see what we got here. I'm definitely sorry to hear that you've had a call on that many times. Let's see. Looks like you're requesting some kilobyte usage that was done while in Canada.
Well, let me just start out with a basic question.
Okay.
Do you recognize that there's a difference between $0.002 and $0.002?
$0.002?
Do you recognize that there's actually...
$0.002.
Yes. Do you recognize there's a difference between those two numbers?
No.
Okay, is there a difference?
No? No? What? Listen, George is patient. So,
Between $2 and...
$0.002.
back
Yes.
up a
Do you
little bit.
recognize there's a difference between those two numbers?
No.
Okay, is there a difference between $2 and 2 cents?
Well, yes, there is.
Okay, so is there a difference between $0.002 and $0.002?
$0.002 and $0.002.
Yes. Is there a difference between...
They're both the same if you look at them on paper-wise.
No, they're not, actually.
For a while, George was selling T-shirts that said they're both the same if you look at them on paper-wise. What is Verizon not doing? They're not looking at I'm looking for a word that starts with the letter U and has an N followed by an I followed by a T. They're only looking at the digits, not the units. So here's the background. Well, let's let George explain because he's being very patient. Remember, he's already been on the phone for about half an hour with another operator trying to explain there's a difference between $0.002 and $0.002. And you've all spotted it, yes? And by the way, a big difference financially in terms of what he was billed versus what he was quoted.
Is $0.5 the same as 0.5 cents?
$0.5.
Is a half a dollar...
That would be 50 cents.
A half a dollar, is it the same as a half of a cent?
No.
Right. So clearly 2 1,000ths of a dollar, which is your rate for airtime, as I now understand it, your rate for per kilobyte in Canada is 2 1,000ths of a dollar. But 2 1,000ths of a dollar is different than 2 1,000ths of a cent. What I was quoted was $0.002 cents. That's 2 1,000ths of a cent per kilobyte.
Okay.
And I specifically asked the rep, I said, are you saying it's $0.002 or $0.002 cents? Because I recognize that there's a difference.
Do you all recognize that there's a difference?
Yes.
So the good news is all of you are too smart to work for Verizon. This goes on, and I'll tell you some more of it. By the way, Adrian, you're at the front. Can you see how long this phone call lasted for? Can you read the timestamp? 23 minutes of this. In the middle, he gets passed on to a manager who accuses George of trying to mislead his employees with tricky math and trying to use number games, and you're being mean to our employees and try. Units matter. Units matter. So the basic background is George was quoted 0.002 cents per kilobyte for roaming in Canada, but he was charged $0.002. A bill of $5.37 became a bill of $537. That's a big difference. He goes on and on and on. I'm not going to play the whole call. If you Google Verizon can't count, you'll find his blog. He actually had to hire a lawyer. Finally, Verizon sent him a letter and a refund, but in the letter, they refused to admit that they'd made a math mistake. But then when his blog went viral, other people who Verizon had overcharged came forward and said, wait a minute, we got charged the same amount. We didn't notice it on our bill, but Verizon can't count. So for the remainder of the year, if you forget to put the units on your answer, or if you put the wrong units, there is a chance I may suggest that you should go work for Verizon. Just saying. You'll get the in joke. Next page. Multi-step conversions using conversion factors. This is why I like this fraction chain method. Because it allows you to use, Liam, stuff you've already memorized just because you're 16 or 17 years old. For example, how many seconds are in 1 week? I always ask, does anybody happen to know how many seconds are in 1 week? Because if you've memorized that, then you're done. But I haven't. Okay. Let's see if we can convert this. What's the first thing we're going to do? Write down what they... What's the first thing we've done on every single other question? Write down what they gave us. What did they give me? 1 week. Although I'm going to abbreviate. 1W. Okay. You guys okay with the calculator there? You're all staring at it? You good? Yeah. Okay. I want weeks to cancel. Where will it go?
On the bottom.
What can you break weeks into? What have you all memorized? What can you break weeks down? You all, I think, know that 7 days is 1 week. And because those are the same, that's a 1. If I stopped here, I'd be done. What do we want to end up with? Does anybody know how many seconds are in a day? If you do, then you could go straight to that. Okay, what can I break days into? Really? You've all happened to memorize how many hours are in a day? That's not something you have to go out of your way and make flashcards for. You just picked up on it. Well, let's use that. Where's days going to go in my conversion factor, Parker? And what can I put on the top? Hours. What number is going to go next to hour? How many hours is how many days? Yeah, 24 and 1. If you wanted to be irritating, you could go 72 and 3, because that's also true. But go with the simplest possible conversion factor. Sure, 24 and 1. If we stop there, we'd be done. Does anybody know how many seconds are in an hour? And once in a while, a kid does know this, in which case we're done. But if not, Parker, let's keep going. What can we break hours into? Really? Have you memorized, hours goes on the bottom. Let's put minutes on the top. Do you happen to know how many minutes make up an hour? Really? Well, that's convenient. Can you break minutes up into seconds for me? Really? Oh. Minutes on the bottom, seconds on the top. 60. And this answers the question. I noticed the 7, the 24, the 60, and the 60 are all on the top. So what will I do with those numbers? Divide them? Times. And I'll ignore the ones. How many seconds are in 1 week?
604.
Read me the digits. 604.
4800.
Units? Units? Seconds. 1 week, little more than 500,000 seconds for those of you who like to know these nerdy things. Here's my point. Oh, sorry, I'll finish doing my canceling just to let myself know I am in seconds. Here's my point. Amrit, I didn't need to use anything that I didn't already know. That's the nice thing about the conversion factor method. Often, with a bit of cleverness, you can tie into stuff that you've just kind of memorized on the fly by growing up. Example 7. How many hours in 1 year? Convince me. Convince me. I'll start out by writing down what they... And again, I would totally give you full marks if you could do it intuitively. But what I'm saying is if you're not sure what to do, write down what they gave you. By the way, the proper abbreviation for year is a lowercase a for annually. Lowercase y is technically yards, because stupid America. If you put a y for year, I won't take marks off, Liz. I'm fine with that. But I'm a nerd. I have to use the correct abbrev. What can I convert years into? Why would I stay away from weeks? How many weeks are in a year? Are there? What? Not exactly. So I'd stay away from weeks. What do I know how many are in a year? I could go to months, but then what would I go to after months? Are the number of days in a month consistent? So I think I would go from years to days. How many days are there in a year? By the way, technically, how many days are there in a year? Braden? Why 365 and a quarter? Okay. And you're technically wrong. It's not 365 and a quarter. We do a leap year every 4 years unless the year is divisible by 100. So the year 1900 was not a leap year. The year 1800 was not a leap year. The year 2000 shouldn't have been a leap year, but there's another correction that we have to do. If the year is divisible by 400, it is a leap year, even though normally it would be divisible by 100 and not a leap year. So the year 2000 was a leap year. And then there's one more correction that we'll have to do in around the year 8000. I won't be there. Hashtag nerd. The universe, the Earth, for the Earth to go around the sun, that's just how long it takes. It goes back to, if I told you, if I was in charge of the universe for 1 day, I'd fix our time system. Anyways, I'm not. So we're going to go to days. How many days in a year? We'll assume it's exactly 365 because we've defined it that way. Oh, how many hours in a day? So days, hours, 24. And so you're right. Somebody, I think Ronan said 365 times 24. Absolutely. And honestly, I've done enough of these that I can do them intuitively. My point is, if you aren't sure what to do, don't leave it blank. I'll get annoyed. Write down what they gave you. At least write down what they gave you. Better yet, after that, put a times and draw a fraction bar. And then I'm hoping the dominoes will start to fall into place. What'd you get? $8,700 and even? And that is units, hours. Cool. Ooh, how many seconds in 1 year? Well, let's write down what they gave you. 1 year. Denzel, what can I go from years to? Denzel, if I'm paying attention to previous questions and if I'm clever, what else could I go from years directly to, because I may have already done a question earlier that lets me get there a bit shorter? Really? You mean I can use previous information to solve another question and save myself some time? Wow, let's do that. That was so clever, Denzel. Well done. So I'm going to put years on the bottom, hours on the top, and I guess the conversion factor is 8,760 is one of those. Denzel, do you know how many seconds are in an hour? Do you know how many seconds are in an hour? No? Then can we go from hours to what? Yes? What am I going to write next to minutes? What number am I going to write next to minutes? Yep. And 1. And now what? Minutes 2. By the way, if you're looking for a shortcut that might be worth memorizing, because it's 60 times 60, there's 3,600 seconds in an hour. That's gravity. We'll look at that later, but we haven't got there yet. How many seconds in a year? I'm lazy. Instead of going 60 times 60, I went 60 squared, because let's use exponents.
Smart little boy right there.
Hey, what I'm really saying, Parker, let's use some of the math you've learned, because too much of the math that they teach you, is useless. But you're going to use a lot of it in physics, and I'll try and show you where it's useful. I got 3, 1, 5, 3, 6, and 3 zeros. If I wrote this in scientific notation, it would be 3.1536. I'd have to write 5 digits anyhow. I think I'm going to write it out longhand because it's not much shorter than going times 10 to this. I'm going to write 31536 3 zeros. How old are all of you, age-wise?
17.
Multiply that by 17. Roughly how many seconds old are you? We won't include the months and the days to your birthday.
89 seconds old. I think my math was wrong.
So, let's see. All of you are about 500 million seconds old. So, today at supper, if your parents ask you, honey, what did you learn in school today? Mummy, I'm over 500 million seconds old. Again, I like to drop the nerd trivia. I don't know if you guys do as well. So, Mr. Dewick's unit conversion method, I always write down what they gave me because I feel better. Liam, did you get that okay? 31536 3 zeros seconds.
Just yelling, like very aggressive.
Well, you got a couple of things you could do. You could also calculate how old your parents are in seconds and then compare it and just make them feel old as kind of an initial conversation starter.
I don't know.
You could, if you're bored, calculate their average lifespan and calculate how many seconds they have left on average. That's a nice little conversation starter. And then you could just count them off, ticking away. Tick, tick. Mommy and Daddy, you're shorter of breath and closer to death, right? I mean, you never know. I don't know what your relationship is with your parents. You're teenagers. No one knows what your relationship is with your parents. Your parents don't even know. Alrighty. So, back to here. Write down what they gave me as a 2-level fraction, or at least imagine it as a 2-level fraction. Look at the units and find a conversion factor with those units. If the original units are on the top, they'll be in the bottom of the conversion factor. If the original units that you want to get rid of are on the bottom, they'll be in the top of your conversion factor. And build your chain crossing out the units when done so that at the end you can see which units are left and they should be the units you were aiming for. That's how I did that calculus question. Next page. If you have a table with conversion factors, you can do stuff like number 9. How many centimeters in a mile? I don't know. What am I going to do first?
Give what they give you.
What did they give me?
1 mile. Right now.
Why would I not use that as my abbrev for mile?
Meter.
So the abbrev for mile. Oh, and the abbrev for minute is MIN, and I may have mentioned already we don't have enough letters in the English language.
Mr. Dewitt.
Yeah.
Why is a foot called a foot? Because my foot isn't 12 inches. I don't think.
You're trying to figure out why some of the terms are called that in the imperial system. They're all just a little bit strange and they have a weird history. So ask me later, I'll dive into some of it if you want. But meanwhile, Parker, let's you and I keep going. Look at the conversion sheet. Is there something I can change miles into?
Miles into meters? What?
I don't know how many miles are in a meter or meters in a mile.
My bad.
Look here. Is there something I can change? Need you to focus, please.
A foot?
Okay, so miles on the bottom, feet on the top. What's the conversion factor? According to this, 1 mile is 5,820 feet. What a stupid system. Imperial. Because, by the way, in the U.S., kids memorize all these.
Oh, poor kid.
They have to. Okay, Parker, miles has canceled. Now I'm in feet. I want to get to centimeters.
When you go from feet to inches.
Okay, that works. So feet on the bottom, inches on the top. And 12 inches is 1 foot. That one I've kind of memorized because I play basketball. Okay, now we're in inches.
You go from inches to centimeters.
Oh, that'll work. And is that what I wanted to end up in? Nice.
Right.
And I guess 2.54 centimeters is 1 inch. Each of those numbers is on the top, so I'll multiply. If any of those numbers had been on the bottom, I would divide. But it's going to be 5,820. Everybody try this on your calculator, please. Times 12 times 2.54. Type this in already, Adrian?
1773936.
Units, Parker?
Centimeters.
I like question 10. I like question 10. I like question 10. Question 10 is a nice question. Why would I say that? Did you hear me say it's going to be on the test? You're the kind of student that notices when a teacher tends to emphasize certain things. Good. Alrighty. Yeah.
What is the average kilometers per hour on highways in Canada?
Highways or freeways. But can we get back to this kind of squirrel distraction? We got to get through the lesson first. Remember that question. We'll come back to it. Now they want me to convert 60 miles per hour to meters per second. Here's one of my strongest suggestions. This is a fraction. That's what that little fraction line means. Never write slanty fractions. Always write two-level vertical fractions. That's why, by the way, I said write down what they gave me as a two-level fraction. In other words, I'm going to write it like this. 60 mile over hour, because by doing it that way, I can clearly see what's on the top and what's on the bottom. Camille, you and I are going to do this one together. This question is going to require 2 steps, actually more than 2 steps, 2 things. We're going to have to convert miles to meters, and we're going to have to convert hours to seconds. We're going to do them each on their own. We're not going to try and do them at the same time. So what do you want to convert first? Miles to meters or hours to seconds? Miles to meters? Okay. What can I convert miles to? Camille, what might be a very convenient thing to convert miles to, because it would be easy to go to meters from that thing? Why don't I use my answer from number 9 and be clever? So I'm going to go like this. Where is miles going to go? On the, and I'm going to put centimeters on top, and here it's going to be 177,393.6 to 1. Now, if I didn't have that, I would walk through the same procedure that Parker and I did, but ending up in meters. Why not use the shortcut? Now I want to get rid of centimeters. So Camille, where is it going to go in my next fraction? What can I put on the top? It's a good question. What can I put on the top? What do I want to end up with? Meters, yeah. And what's my conversion? What's centi? 10 to the what?
2, negative 2.
Where's the 10 to the negative 2 going to go? Where the centi isn't. So if I stopped here, that would be meters per hour. Now we need to take care of the hours. Are you ready? Where is the hours originally? On the? So where am I going to put it to get rid of it? On the? Yes. What can I convert hours to? Do you happen to remember how many seconds there are in an hour? I dropped that tidbit about 5 minutes ago planning for this question. You remember what it was? 3,600. Since you remembered, your lips didn't even move, but that was pretty impressive. Let's use the fact that 1 hour is 3,600, and we saved ourselves one conversion term. So I guess it's going to be, now, everybody has their calculator out. Does everybody still have this staring at them on their calculator, that answer? If you haven't figured out, your calculator has an answer button, which is hugely useful. I'm going to go like this, 60 times, and I'm going to hit my answer button. That just drops down my previous answer. I don't have to retype the 177,393.6. You want to find where your answer button is. Times 10 to the negative 2 divided by 3,600. I'm going to use that answer button an awful lot, so you want to figure out where it is. It cuts down on your typing, it reduces error, and it's less work. It's a triple win. I got 29.5656, and not repeating. Is that right? Anybody else?
Yeah. Meters per second, Mr. Dillon. Don't forget the units.
Or I'll work for Verizon. A couple more, we're done. I've been talking a lot, but this is a topic that kids find tricky enough that I wanted to do lots of practice examples. So thank you for your patience here. Convert 3,500 gallons to milliliters. Okay. What am I going to do first? Why can't a lowercase g be the abbrev for gallons? GA is the abbrev for gallons. Is there a conversion? I've scrolled down. In that chart up there, is there a conversion factor that I can use with gallons?
Or you could do liter.
Is there liter?
Yeah.
Why would liter be better than quart? Because I want my final answer to be metric. Why don't I go metric as soon as I can? So you're saying I can put gallons on the bottom and liters on the top? Yeah. What's the conversion factor? How many liters is how many gallons? Is he lying? Is there not a conversion factor?
Yeah,
oh, okay. Sorry, I thought I'd get... Matt, I don't have that there at all.
I just tricked you.
I was trusting you. Clearly, I won't trust you again. Note to self, never make that mistake again. So what can I go from gallons to what? Gallons to quarts? How many quarts is how many gallons? I have no idea.
5 gallons.
Sorry? Oh, is quart short for quarter of a gallon? Oh,
what?
Wow.
This is crazy. It's like the Verizon phone call. Yeah.
What can I go from quarts to?
Liter.
Is it on there?
Yeah. So it's 1.0567 quarts is 1 liter.
Read that again.
1.0567 quarts is 1 liter.
If I stop there, that would be liters. I want milliliters. So where is liters going to go in my next fraction? Milliliters on the top. Milli. Is that 10 to the negative 3?
Yep.
Where's it going to go? Where the milli isn't, which in this case is on the bottom. So Nick, I think I'm going to go 3,500 divided by 0.25 divided by 1.0567 divided by 10 to the negative 3. Okay. Who's calling my beloved name? Yep. You could move it to the top and multiply by a positive 10 to the 3, but all I'm saying is I've got a method that works. Again, if you're getting the right answer, I don't care how you do it. And there's all sorts of shortcuts. But that would be putting a power of 10 next to a metric prefix, which is not the method that I'm teaching you. It works, but do y'all get 1324873.41?
Yeah. That is what I got.
Yuck. Okay. 1324873. 1324874. No, that was wrong. 48793.41 milliliters.
Is this time per year?
I don't know. Let's find out. Good question. First thing, I noticed this has one of those slanty fractions. I'm not drawing it that way. I'm drawing clearly like that. My units are going to be, I guess, a capital T, lowercase m, and year, which I use an A. And I guess the 4,356 goes there. What's that capital T in abbrev for?
Tera.
Oh, tera. This is a speed, 4,356 terameters per year. We're going to convert it to kilometers per hour. That's how I know it's a speed, because I know kilometers per hour is a speed. I'm going to first of all convert terameters to kilometers, and I'm also going to convert years to hours. Doesn't matter which one I do first, but I just don't do them at the same time. I do them one at a time. So, Arsh, what do you want to convert first, terameters or years? I don't care, pick. Okay, where is terameters going to go in my fraction? On the? Yes. And it's going to go to meters. Tera, 10 to the... Arsh, what is it? Tera, 10 to the 12th? Someone asked a good question. Liam, what was your question? How do I know? I always go to get rid of the tera, and I convert it. So my first step is to get rid of this. So I'm going from terameters to meters, or teragrams to grams, or teraliters to liters to get rid of the tera. That's step one. Okay? Then step two, Arsh, let's keep going, kiddo. I'm going to get rid of meters on the bottom. What do I want to bring in? Yes. What's kilo? 10 to the, I think, 3? Where's it going to go? Where the kilo isn't. So if I stop there, that would be kilometers per year. Now let's take care of the year. Where is the year right now? On the? So where will it go in my next fraction, Arsh? On the? What do I want to convert it to? Do I have have I done that? Oh!
Wow.
I have this conversion fact. I mean, I could walk through it again, but apparently 1 year is exactly 8,700. Okay, let's do that.
That's crazy. It really is.
And if I cross out my units top and bottom, can you see, notice what's left? Kilometers per hour, and I've got them in the right location. This is how I did that calculus question. I got my units in the right location after building this massive chain, and so I figured, well, as long as I do the numbers correctly, it's got to be the right answer. But there was a calculus way to do it in one line. What do you got? We're almost done.
497260274. Oh, whoa. I didn't get that. Maybe I did something wrong, which is highly plausible.
And so one of the things one of the other reasons I'm having you always follow along on your calculators, you get better on your calculators and you make less typos and less mistakes. I got 497260274. Yep. So you were correct.
Oh, yeah.
Yeah, the weak link in the chain is pretty obvious here, right? Do I write that in scientific notation and round off? Well, let's write it out. Parker, can you read me the digits again?
497.
Yep.
260274. 274.
And that is kilometers per hour. If I put in some commas, yeah, 500 million kilometers per hour. That's pretty fast. Okay.
I'll help you. It's not a big deal.
It is. He said getting mad.
Let's win the lottery. Turn the page.
The odds of winning the lottery are so low.
In 2017, Mavis Wanchik won the largest prize in U.S. history. She won $758.7 million.
How do you even spend that much money?
Let's have fun spending that much money. That's a great question. A says this: suppose she spends $1,000 a day. How many years will it take for her to spend the money? Come on, you've wondered these questions with these big prizes. Let's see if we can use some dimensional analysis. Now, the first thing we need to realize, we need to figure out is how many days it's going to take. And to do that, we're going to start out by writing down what they gave me, 758.7 million, folks, is 10 to the 6th, and I'm going to abbreviate instead of writing all the zeros. That's how much she's starting with. How much do we want to spend per day? So what I'm going to do is I'm going to divide that by $1,000 per day, and that's going to tell me how many days. So on my calculator, 758.7 times 10 to the 6th divided by 1,000. And I get it'll take her 758,700 days. This is what I'm starting with. This is what I'm going to write down what they gave me. Wrote that down wrong already. 758,700 days. What do I want to convert this to? Do I know how many days are in a year? Yeah.
I'm just taking the sine conversion by 5,000.
Yeah, you can do this. As I've said several times, there's plenty of shortcuts, and if you can get the right answer, I'm deliberately not showing you any shortcuts because I know those of you that are stronger at math, you'll find them yourself, you'll check them yourself, and if they work, use them. But I'm giving you a one-size-fits-all. I want days to cancel. I want years, and I guess it's 1 year, 365. So divide that by 365. How many years will it take?
2,000.
Can she spend that in her lifetime at that rate? She needs to spend the money faster. That's a nice challenge. So for now, we'll go 2,078 years. Let's spend faster. Instead of $1,000 a day, how about $500 an hour?
That's a little bit quicker.
We're going to, again, start with 758.7 times 10 to the 6th, but we're going to divide it by 500 to see how many 500s she needs to spend, and then we'll figure out how many hours that will take. So how many years that will take. So I'm going to go 758.7 times 10 to the 6th divided by 500. This is how many hours it will take. I get 1,517,400. I want to convert that to years. Hey, I wouldn't by chance have a conversion factor somewhere that relates hours to years, would I? That would be convenient if I did.
You do. You silly goose. How many hours? 8760.
So if I put hours here and years here, 1 year, 8760. So if I take this number and divide by 8760, if she spends $500 an hour, 24/7, not spending time to sleep or eat or anything, can she spend that money in a lifetime?
Not even.
173 years.
She needs to do it.
Well, I fibbed a little bit. You see, actually, When you win a lottery, especially a really big prize, they give you an option. You can either get it in payments spread out over 25 years, or you can take a smaller lump sum up front. And she chose to take, I'll use air quotes, a smaller, air quotes, lump sum up front. She took the $480.5 million up front instead of the 787 spread out over 25 years. Why would people choose to take the money up front?
So they can pay off everything.
You can pay off anything you want to with that, regardless of whether you having it spread out. Why would some people choose to take it up front? Yeah. I mean, if you're elderly, you might want the money now, right? Okay. Alrighty. So now instead of 700 and whatever million, 480.5 million, and she's going to spend $10 a minute. Can she do that in her lifetime? Well, let's write down 480.5 times 10 to the 6th. We'll divide that by $10 per minute, and that's going to tell us how many minutes. So get your calculator out. I get 4805 and 4 zeros. That's how many minutes? 4805, 4 zeros, minutes. I want to convert that to years. What can I convert minutes to? Hours, you say. Where's minutes going to go?
On the bottom, line.
Hours on the top. Not because we don't want it anymore, because minutes was originally on the top, so to get it to cancel, it goes on the bottom. Had it originally been on the bottom, to get rid of it, it would have gone on the top in the next one. So we got to be careful. We can't just say always on the bottom. Right. And I guess 1 hour is 60 minutes. That gives us hours. It'd be really nice if there was a conversion factor that related hours to years.
Well, there is.
There is, you say? Really?
You already have the number.
So take that number on your calculator, divide by 60, and divide by 8,760. If she spends $10 a minute, 24/7, not taking any time to eat or sleep, is it theoretically possible? And remember how I started this lesson with the pennies? You're realizing even 480 million, that's a big number to wrap our brain around. Because can she? Well,
If she won the lottery when she was born, possibly.
Yeah.
and does nothing but spend money. This is a lot of money.
That's so cool. Well, you gotta think about it. There'd be big expenses too. Like, she'd have her phone bill, her insurance. Her, like, when she buys a car,
Okay.
when she buys a house.
Mr. Dude, what would you do if you won the lottery? Like, first thing.
Blow up the
I win the lottery every week because I don't buy 7 tickets each week.
You change the calendar.
I win $7 a week by not buying a ticket each week.
You would change the calendar.
I think you buy like a sick card.
Okay.
You buy a calendar and then you write your name.
I've talked for a while, so I'm going to do this. I'll start on Monday with this little thought puzzle called Fermi Problems. Instead, I'm going to give you some homework to practice with.